Welcome back to All This Math, and for today's lesson we're going to get into some subtraction. I got two examples up here. The first example includes two integers, right? Numbers that don't have a decimal or a fraction part. And the second example includes two rational numbers or two fractions, basically. So number one, we're trying to figure out what is negative 6 minus 8. What is negative 6 minus 8? All right. So when I see a problem like this is how I approach it. I always think of the number line. In my head, ever since like back in the day, I remember learning about this probably like around the 6th grade, if not earlier, but I always picture a number line in my head. And on this number line that's in my head, I start at negative 6. And because there's a minus sign, right, after the negative 6, that tells me that on that number line that's in my head that I'm picturing right now, as we speak, I'm picturing this number line right now, real talk. I'm moving to the left. The minus sign tells me to move to the left on the number line. So imagine the negative 6 was like right here, right? Let's say the negative 6 was right here. And I would start there at negative 6. And then the minus sign tells me to move to the left in the left direction. If there had been a plus sign right here, I would move to the right. Plus sign means move to the right. Minus sign means move to the left. So, and then the second number tells me how far to move. So I would go 8 spaces. So then I would be like negative 7, negative 8, negative 9, negative 10, negative 11, negative 12, negative 13, negative 14. That's 8 spaces. That's 8 spaces. So that means that negative 6 minus 8 is equal to negative 14. Negative 6 take away 8 is negative 14. Remember, the first number is where you start at on the number line. The minus sign tells you to go to the left. The second number tells you how far to go. Because you need your direction and your distance. Your direction and your distance. Your distance and your direction. Your starting point. That's all it is. Keep it simple. Relate it to real life. But try to relate it to real life. This is where you start at. This tells you whether to go left or right. Because it's a minus sign, it tells you to go left. And this tells you how far to go. Direction and distance. Direction and distance. All right, you end up at negative 14. Now, another way to think about this is negative 6. That might represent a debt that you owe. You might owe somebody $6, right? And then minus 8, minusing, meaning you borrow some more money, right? You're subtracting, so you're borrowing more money. So you're borrowing $8 now. You already owe somebody $6. Now you're borrowing $8. Now the question is, how much do you owe altogether? That's the way to look at this problem. So altogether, you owe $14. And because you owe, that's a negative value. That's not money that you may possess the money, but you still owe that money to somebody else. That's not really your money. You know what I mean? That's why it's a negative value. Even if you have $14 in your possession, you have a negative 14 balance because you owe someone that $14. Or you might owe multiple people parts of that $14, So that's that. Now, let's go on to number 2. Number 2, we're dealing with fractions. Now, I know anybody watching this video, you might be scared of fractions, you might hate fractions, you might dislike fractions. Fractions should be your friends. Fractions should really be your friends. And fractions are not really difficult if you understand the concept behind them. So here we have a negative 3/4, right? And we're subtracting 2/3. This is similar to this problem. We started with a negative and we're subtracting. Here we started with a negative and we're subtracting. Only difference is these are fractions of a whole. These aren't whole or whole numbers. Technically these aren't whole numbers because they're negative, but at any rate, these are fractions. In order to add or subtract fractions, you first need a common denominator, or else we're dealing with apples and oranges and we can't really add or subtract. So we need what's called a common denominator, And preferably you want your lowest common denominator. So your teacher probably used an acronym called LCD. LCD stands for lowest common denominator. Lowest common denominator. Some textbooks, instead of the word lowest, they use the word least or least common denominator. But it varies. Those terms are synonymous, least and lowest. But anyway, so you look at the 4 and the 3. These are your denominators right now. We can't do subtraction because of that. We can't do subtraction until our denominators are the same or they're common. So we want to ask ourselves, what is the smallest multiple of 4 and 3. Or the smallest multiple that they share. When I say 4 and 3, I mean that they have in common. That's where the C from LCD comes from. Matter of fact, let me write that down because that's important. You need an LCD. LCD. Yeah, you need an LCD. So ask yourself, what is the smallest multiple that 4 and 3 share? It's 12 because 4 times 3 is 12 and 3 times 4 is 12. So 12 is the smallest number that is a multiple of both of those numbers. Think about what I just said. 12 is the smallest number that is a multiple of both of those numbers. Now, what's a multiple? A multiple is a number that you get when you multiply a certain number by another number. 12 is a multiple of 4 because if I do 4 times 3, I get 12. So that's why 12 is a multiple of 4 because I can do 4 times 3 and get 12. Now, it's just a coincidence that that happens to be a 3 and I'm doing 4 times 3. That's just a coincidence. 24 is also a multiple of 4 because I can do 4 times 6 and get 24. 24 is also a multiple of 3. So you might be wondering, well, why can't we use 24? Because that's not the least. That's not the least. You want the least common denominator. You don't have to use the least common denominator, but if you don't use the least common denominator, that makes the math more complicated, and you'll likely have to reduce when you finish the problem, whereas you might not have to if you use the least common denominator. But anyway, our LCD is 12. So we're going to rewrite the problem with new denominators. So we're going to replace the 4 and replace the 3 with 12s. So we'll do this. That's going to be a 12. So this fraction is going to be rewritten with a denominator of 12. That's my minus sign from right here. And then this second fraction is going to be rewritten with a denominator of 12. All right. Now, next question is, what are my numerators going to be? What are my numerators going to be? So this was negative 3/4. So this is still going to be negative. So I should put my negative sign right here. This was 3/4. Now it has a denominator of 12. So the easy way to do it is you say to yourself, well, what did I multiply by 4 to get 12? I multiplied by 3. So you do 4 times, write that times 3 right there. So and then you think to yourself, so as it is below, so it is above. As it is below, so it is above. If I multiply the denominator by 3, I got to also multiply the numerator by 3. What's 3 times 3? That's 9. And then I go over here, and I'm trying to figure out what numerator goes up here. Now, how did this 3 turn into a 12? I multiplied it by 4, because I know my multiplication facts, and I know that 3 times 4 is 12. So if I did 3 times 4, I got to also do 2 times 4. See? Here I did times 3 and times 3. Over here, I'm doing times 4 and times 4. 2 times 4 is 8. Now I got 9 twelfths minus 8 twelfths. Now I can do the subtraction. You can't do the subtraction until your denominators are common. We can't do this. We can do this though. See, we got common denominators. We got common terms, right? It's almost like you speaking the same language, right? Because now this fraction can have a conversation with this fraction, right? Here, these two fractions, they can't really converse with each other because they got different denominators. So it's as if they're both speaking different languages, right? Now, this fraction is broken down into twelfths. This fraction is broken down into twelfths. Before, this fraction was broken down into quarters, and this fraction was broken down into thirds. They can't really get down with each other. Not with addition and subtraction. With multiplication or division they could, but not with division, not with addition and subtraction. But now we're doing negative 9 twelfths minus 8 twelfths. When we get to this part, we're only concerned about the numerators because the denominator is not going to change. The denominator is just that. It's a denominator. It just tells you what type of unit you're using, basically. So I'm going to write my equal sign right here. I'm going to go vertical. And I'm going to do negative 9 minus 8. Negative 9 minus 8. Now, negative 9 take away 8. Remember what we did in the first example? If you start out at negative 9, right? And I don't have enough space up here to actually show what's going down. But if I started at negative 9, right? And if I'm subtracting, remember, the operational symbol tells me what direction I'm going in. Because I'm subtracting, that means I'm moving to the left. And then this number right here tells me the distance. How far am I going on the number line? So if I start at -9 and I'm going 8 spaces to the left, I'm going to end up at -17. So that fraction is still negative, and the denominator is still 12, and I end up with -17/12. -17/12. -17/12. That's what I end up with. Because I started at -9, I'm subtracting, so I'm going to the left. How far am I going? I'm going 8 spaces to the left. I stop at -17. Now, -9 minus 8, I also think about that like this. Like -9 is similar to owing $9. Subtracting 8 is similar to borrowing $8. And altogether, the question is, how much do you owe? Altogether, you owe 17. Because you already owed 9, now you borrowed another 8. Put them together, 9 plus 8 is 17, except it's a negative value because we started with -9 and we went deeper into the negative by subtracting, moving to the left on the number line. So that's -17/12. All right. Now, just in case you have a teacher that wants you to convert improper fractions into mixed numbers, first off, what's an improper fraction? An improper fraction is a fraction where the numerator is bigger than the denominator. The numerator is bigger than the denominator. So if your teacher wants you to convert that into a mixed number, it's what you do. You look at the denominator, ask yourself, how many 12s can fit into 17? Only one. 12 can only fit, 12 goes into 17 one time with a remainder, but no more than one 12, group of 12 can fit into 17. It's kind of like this. It's like if you and some of your relatives or your friends go to a restaurant and they have, let me see, groups, it's a group of 12 of y'all, right? Y'all all need to, let's say it's 2 groups of y'all, right? But y'all all need to, no, actually, let's say it's 1 group of y'all. Y'all all want to sit at one table, right? But it's 12 of y'all. So 12 of y'all can fit at one table, and actually the tables have 17 spots, or 17 chairs, right? One whole group of y'all, the whole group can fit. That's why the whole number part is 1. And how many chairs will be left over? 5. 17 take away 12 is going to be 5. So that's going to be your numerator. And the denominator stays the same. Because again, that's how many of y'all it was. It was 12 of y'all. And don't forget that this was negative. So the mixed number is also going to be negative. All right? So we got -1 and 5/12. Or -17/12. All right? -17/12. All right? I think -17/12 is a better answer, because what happens is when you get to algebra and you get to higher level math, we're not using mixed numbers anymore. You really don't see these. You see improper fractions all the time. All right? But it's good to know how to do the conversion, though. That's important. All right? So now I showed you how to do these problems, but the way you're really going to learn it is by doing practice. You got to go practice. All right? So go out there and get some practice. And I'll see y'all on the next video. Peace.